Okay, so over to you, Dave.
Okay, thanks very much. Good afternoon or good morning, good evening, whatever the case may be. Thanks for having me. It's great to be here on a hot Friday afternoon talking about a cool subject. And so we'll get right in it. A little bit about me. I'm a degreed electrical engineer, and marine is actually a second career. And I'm seriously considering moving into it because it's really interesting, and we've had a great opportunity to help move the industry along, and we've done some cool projects. But my other life is in the data center industry, where I have many years of dealing with the backup power, not the computers. So I'm not an IT geek, but making sure that computers in data processing facilities have a clean supply, continuous supply of power that's in spec, and that their environment is what they want, which is temperature limits and humidity limits and all of that. And most of my career in that industry has not been at the design table or at the CAD station. It's been out in the field with testing, commissioning, failure investigation, site assessment, that sort of thing. I'm naturally a hands-on guy, and so 40 years of sitting in an office or the CAD station isn't my thing. And I'm from the Philly area, a little ways north of here, and we'd go to the Jersey Shore for vacation, and that's where I learned to sail. We moved up to various larger boats. We went cruising in the Bahamas. I finagled a partial sabbatical where I was working at the time. And everything was great about being in the, who doesn't want to be in the Bahamas, right, in the winter? But when you have diesel engine problems in the Bahamas, it's not good. And so we started looking at electric as, and being an electrical engineer, I can't help myself but think about electric. And so we saw the first, at the Annapolis Boat Show, which is a fairly big event. The first time I saw anybody with electric was '04, and it was not a fully baked system. But we started to see things come together, and we started a company in 2010 focused on electric propulsion, but it became clear that solar was going to be part of it. So we started offering solar in 2013, sometimes with electric propulsion, but not always. So this presentation, I do have some live demonstration equipment that I want to show you, but it's more conceptual than it is nutsy boltsy. So the first part of it, I'm going to talk about the nature of solar, which some people tend to gloss over. It's a really important subject. Next, we're going to talk about where solar fits, where it shines, sorry, pardon the pun, and where it doesn't. Next, getting the most out of a solar investment, and then what you as surveyors, what I believe you should look for when you're aboard a boat that's got solar. Then we'll have plenty of time for Q&A. I'll move through pretty quickly and not go too far into the weeds on things. So let's talk about the nature of solar. One thing that we electrical engineers often have a difficult time explaining to people outside our field is the difference between a soft source and a hard source of electrical energy. The bad news for solar is that it is a very soft source. It is one of the softest sources of energy around, electrical energy. But there is good news coming. So when we talk about a soft source, we're talking about a source where the voltage is all over the place. It's not very stable, and you have to work with it. You can't use it as a raw material. So you're probably wondering, okay, if he's talking about a soft source, then there must be hard sources, and there are. Those outlets ultimately connect up through the building's electrical distribution system, out to transformer, out to a service entrance, out to the electric utility system. It is an extremely stiff and extremely hard source. You could build an arc furnace a couple miles from here, connected to the grid, and when you fire up that arc furnace, you're not going to disturb the grid's voltage. The grid has hundreds of generating sources and all manner of interconnecting and control means to keep that voltage stable. So when we talk about a hard source. We're talking about one that where the voltage stays where it is, no matter what you throw at it. And the other thing is that it can provide a high current to blow a fuse or trip a circuit breaker. That's a hard, stiff source. Solar is not that, not at all. But the good news is we have technology today that's gotten a lot better that manages the softness. You don't have to worry about it. And the result is when you use solar properly, it's very cost effective and can do a lot of things that other sources for boats can't do. One thing that I think certainly the press and media have greatly overlooked, even the scientific press or engineering press, or like Popular Mechanics, what tends to make news are innovations that happen all at once, right? When a technology gets a little better step by step by step by step over the years, we tend not to pay too much attention to it. But I promise you, if the solar innovations, the tiny little steps, dozens and dozens of them that have happened over the past 10 to 15 years, happened all at once, it would be all over the news. It is truly remarkable how much better today's panels are in terms of what they can do for their cost. And that's why you read articles about how renewables are becoming cost effective in a lot of places, and you're seeing unused farmland getting covered in panels. So that addresses the nature of solar. Now, where does solar shine and where it doesn't? This may look like a crude situation, but this is actually a very clever solar application. So beneath the panel is one of the electric outboards that we sell. This is the ePropulsion Spirit 1.0. It is a 1 kilowatt motor, equivalent in torque at the prop to about a 3 horsepower gas engine. They become very popular among cruisers and fishermen who fish in lakes where combustion engines have been banned. ePropulsion sells an MPPT charge controller. We'll get into those later. And this customer is not one of our customers. We're one of 47 different dealers that offer this technology. But a friend of mine in Florida snapped this photo and talked to the owner. And the owner says, I haven't plugged my battery in to charge it in months. Now, this guy is down in Florida. And think about what this panel does for him. It doesn't interfere with the use of his dinghy. And he's a cruiser, so he's living aboard. He's on the hook probably more often than he's at the dock. And so to be able to get around the way he needs to without having to worry about taking a transit slip for a night so he can plug in, that's a big deal for him. So it may not look like the coolest thing in the world. It may not look like the most structurally sound thing you'll ever see, but from an application and concept standpoint, it's a home run. It totally works. All right, 2 things. If you're a solar panel, there are 2 things that you love: real estate and time. So this panel, for example, is about 100 watts. And so if it's in full sun for an hour, you'll get 100 watt hours out of it. And depending upon the application, that can be a lot or not a lot, depending on what you're trying to do. So we get inquiries from people that want to do electric boat projects. They'll tell us, I want to take a sport fishing boat out to the canyon at 18 knots, and I want to do that on solar only. No, I'm sorry, that is not going to work. Solar does not shine, again, pardon the pun, in that application. Why? The question you have to ask that person is, how many barges covered with panels are you willing to tow behind your sport fishing boat? So it's not feasible. So in other words, an electric motor to power a sport fishing boat at 18 knots is north of 100 kilowatts. And this is a 100 watt panel. So that's why that's where this idea comes from about real estate and time. So buildings with flat roofs are easy candidates for solar. Unused farmland, easy candidates for solar. But that doesn't mean solar doesn't have its role to play. One of the key themes here is solar has a big role to play and an important role. when it's used correctly. So the MPPT, if you're not familiar with the acronym, maximum power point tracking. And a good way to understand MPPT, who here has grandkids? All right, so you ever notice, like, you want to get your grandkid to help you with the lawn or mow the lawn or do something around the house. And, you know, at first they're really, really interested. And then after 5 minutes, they're bored, they want to do something else, right? So what you do in that situation is you try to get some useful work out of them, but when you reach that point where they aren't interested anymore, you don't push too hard. An MPPT does something similar. It takes from the panel whatever the panel is willing to give at the time it's willing to give it, right? And it prevents the battery or the rest of the system that wants energy from trying to take too much from the panel more than the panel can give. These devices have become very sophisticated. This one, for example, even has Bluetooth, so you can see what it's doing on your phone. You just download an app, it's very easy. So when you put these ideas together of real estate and time, what do you get? Well, number one, catamarans definitely have an application advantage because there's more surface area to install panels. And another very important application for solar is if you keep a boat on a mooring and you're not there all the time. If you have a cottage on a lake and you're there every other weekend or something like that, and you want to keep your batteries fresh. Solar is very good for that because now, even if it's a monohull, it may not have that much real estate, but you have time. You have 2 weeks maybe, or 1 week. Even in 1 week, it can do a lot. And this is really important for our customers who are doing electric propulsion with lithium batteries and keeping a boat on a mooring. Why? Well, lithium, if you let them discharge too far, there's a point of no return where it's dead and not coming back. And so rather than paying somebody to go out in a dinghy to your boat on a mooring and charge it, the solar system can do that, can keep that battery, even if it can't bring it all the way up to a full charge, it can keep it from declining to that point of no return. So how do you get the most from a solar investment? What we advocate is that you think of it as part of a larger picture where we have energy sources, we have ways to store energy, batteries, but down the road we may have other ways. And then we have loads or energy users. So what we try to do for our customers is figure out how can we get all the energy sources working together without damaging each other or fighting each other. And how do we get the array of sources to work correctly with the batteries and have the resulting system able to support all the loads. So when we get inquiries from customers about these kinds of situations, we do a lot of a lot of dialogue. We do a lot of investigative work to figure out what do they have, what are they trying to operate, what are they trying to do. Operating air conditioning without a generator running all night and making noise, that is something we hear frequently. Solar by itself can't, of course, do that. But we can integrate solar with other technologies to make that happen these days. So I think it's important to understand what solar can and can't do. Solar can supplement engine alternator charging of batteries or generator charging of anything else that's charging a battery that may or may not be present. So solar can easily these days integrate with that, not interfere with it. Protect batteries from excessive discharge, like the mooring example. And we also have applications where, no, the panels alone can't handle an electric propulsion load, but they can help, they can contribute, they can extend range. So in a situation where a battery may be enough to power, say, a low speed a power boat or something like that for 4 hours. Maybe you get another hour if the or maybe an hour and a half with the solar. So we do have people that ask, well, can I put solar panels in the boat and then run my air conditioning all night long without the generator? No, that's unlikely to happen. And no, you can't run an electric speedboat on solar alone. And no, you can't start a diesel engine with a solar panel. I mean, these are things people ask. All right. So in the next couple of slides, I'm going to get into some of the nuts and bolts of things to watch out for, things that we have seen problems with, and that U.S. surveyors can be on the lookout for, and then give your clients good input on what to do. So today's MPPT charge controllers are very sophisticated, but there is still some work you have to do to apply them correctly. And it's important to look at the specs when you're looking at a specific product. And there are two key parameters to look at. Number one is, what is the maximum voltage from the panels that the unit can accept? And number two, what's the turn-on voltage for that product? So number one, this particular product that I got the spec from says 75 volts. So they don't want to see on the input more than 75 volts coming from the panels. And it says open circuit. What that means is, if the panel is sitting there and nothing else is happening, it's connected to the unit, there's no load on the unit, they don't, it's a maximum value, right, that the panel would ever operate at. Now, this panel is never going to be above 24, so you can parallel this panel, and this particular product will handle it very easily. Or you can put two of them, maybe three of them in series, but three of them in series, you're going to get very close to that maximum. So that's something to pay attention to. And number two, this little bit of gobbledygook here, I'll explain it. The minimum input voltage. An MPPT can't do anything with the energy that's available from the panel unless the panel voltage gets, for this one, and this is a very typical value, 5 volts above where the battery is now. So if you have a 12-volt battery that's sitting at 12 volts, your panel's got to be at 17 or more before anything happens. If the battery's sitting at 13 and a half, now you need 18 and a half, right? There's a 5-volt window, a threshold that you have to have. And then what this particular product spec is saying here is that once you get it going, once you hit that 5-volt threshold, once that panel gets to 17 for a 12-volt battery or 18 and a half for a 13 and a half volt battery, then once it starts, the panel voltage can decline to VBAT +1. So if the battery's sitting at 13 and a half, the panel voltage can go down to 14 and a half, it'll still work. If it goes down to 14, it shuts off again, and you have to repeat the whole cycle. These are things that, in interacting with customers and some installers, this was news to them. This was like a bit of a revelation, or they didn't really understand it. All right, so once you have that picture understood, now you can think about, all right, how on a given application can I configure the panels so that they spend as much time as possible in above that threshold where the MPPT will work, right? And what happens, another thing we frequently run into is that most of our electric propulsion equipment is 48 volts. Well, what do you do with a panel that's never going to be above 20, 21, 22, max 24? There are some companies making what we call boost controllers. And if they cost a little more, well, that cost increase is justified because that controller has capabilities that the standard MPP does not have. It is able to actually convert the solar energy to a higher voltage and a lower current to get the voltage up to where it has to be. So with a boost controller, you can parallel panels like this that never get above 24, and you can connect the output to a 48-volt battery, and the boost controller will make that, it will convert to the higher voltage. One of the products that we use that does that is Genasun, and they make their product for lead acid and for lithium batteries, and that solves the voltage problem. If you don't have a boost controller, then what you're looking at is putting panels in series. And I was skeptical of this when I first heard it, but it turns out to be true that panels in series just don't do as well. The energy harvest at the end of the day, when you look at the numbers, is not as good. So we have become big believers in the boost control concept. Then there's a complication that comes into play when you put solar panels in series. If you don't use what's called a bypass diode, then shading on one panel is going to cut all of them off, and it just doesn't work as well. So we steer clear of series connections with panels whenever we can. And then low sun angles. This is from Sunbeam. This is a Swedish company. Their panel technology is very good at generating energy even when the sun is at a low angle. So when you look at the total harvest for the day, this one will start producing maybe at 9:30, 10, whereas an older panel may not do anything until the sun is high, or it's say 10:30 or 11. Also, you have to think about shading. If there's an object that's going to shade the panels, you want to arrange the panels in such a way that you don't that the shading knocks as little out of the system as possible. So you can arrange the panels, which ones are connected to the others, and you can parallel MPPTs, even the boost MPPTs on the output. Since they're all going to drive to the same voltage, they'll be fine. So what I would think as an engineer, surveyor should be looking for if you happen to be asked to survey a boat that's got solar on it. The first thing I would do is think about the concept. Why is the solar panel there on that particular boat? What job is it there to do? And that way, yes, of course, if you have a situation where the solar panel is installed in such a way that there's a screw that goes into a core deck and there's no sealant, and now water has gotten in and started to rot out the coring, of course you want to note that as a surveyor, but I would encourage you to start at the concept level first. So that way, if your customer thinks, oh, there's solar on this boat, and that's a really great feature, and that means that it can do this, this, and this. If you understand the concept, well, maybe the boat owner who's selling the boat, maybe he didn't buy solar, or didn't do the solar project to do all those things. So maybe he kept it on a mooring and just wanted battery protection, or wanted to have some supplemental energy for whatever purpose. So if you understand the concept behind why the solar is there in the first place, then I think you can give your client good guidance on the whole situation. Then you go into the implementation. All right, were the panels installed in a way as to not compromise the structure of the boat? They're ABYC standards, and I didn't mention earlier, I am certified by ABYC as an electrical advisor. So you can look at the wiring, and was an effort made to comply with ABYC in terms of wire protection and support and all of that. And are there fuses and circuit breakers in proper locations? We always fuse the outputs of the MPPTs, not because the MPPTs can source a lot of fault current, they can't, but the battery can. So it's more to protect the unit than it is the battery. And then did somebody go through and set up the MPPT correctly? So that blue Victron unit I showed you, it's a very sophisticated unit. It can charge 6 or 7 types of batteries but you have to go in and tell it which type of battery it's charging. So did somebody do that? That's important. And another gotcha with lithium batteries, in addition to their going into a death spiral if they're left uncharged for a long time, they can also be compromised by overcharging. So we take great pains to make sure that the battery, there's an active means with a BMS that has some kind of a relay output where we can use that to turn the MPPT off, or we know that the battery has a maximum voltage, and we can, if we don't have a relay, if it's an internal BMS battery and there's no way to get that information out of the battery that it doesn't want to be charged anymore, we can know where that voltage is and force the MPPT to never go above it. So the MPPT can be on all the time, but its voltage will never go above, or with some headroom. Let's say a lithium battery, you got a lithium battery at that never wants to see more than 14.8 volts. Well, you can dial the MPPTs down in tenths of a volt. So if you don't have an active means of turning it off, what you can do is just say, hey, Mr. MPPT, don't ever go above 14.4 ever. And that will achieve the same result. All right, so I went through that pretty quickly. In order to have some time to do a little show and tell here, and I'm going to try to move my panel here into where the camera can see it. And also, I've got a meter connected to the panel. And right now, I don't know how readily anyone can see this, but we've got just under 11 volts on the panel. Okay. And what I'm going to do, I have a little light set up here. So I've got a light that I'm going to shine on the panel. And you notice now we're up to 16, over 16 volts, right? So I move the light away. And now we're back down, right? So now we're back down to about 11, now we're 12 or so. This is a little tricky to do, but the point being is that this is what I mean by a soft source. If you learn nothing else today, understand what we mean by a soft source. Slight changes in the amount of light energy hitting the panel greatly affect the voltage. And I've had people ask, well, why do I even need the MPPT? Well, a panel that's where the voltage is all over the place, you're not going to get any real charging out of, right? Because you need to charge a battery, you need to have some control over the voltage, and that's what the MPPT tells. So is this clear? I know I've gone through this pretty quick, and happy to entertain any questions. Lightning. The short answer is no. Lightning protection to me is a black art, and I don't think there's anything really. I don't think there's much you can do to make a solar installation lightning resistant. I'm actually glad you asked that question, because I actually do have a customer whose boat was not just struck by lightning, but bombarded by lightning, a very severe lightning strike that fried pretty much everything on the boat. This customer is actively looking for a surveyor to help represent him to the insurance company. So if anyone is interested, I will connect you with him. I have business cards. This poor guy, he's Swedish, and he works in the auto industry. He's fairly high up at whatever supplier or company he works in, and he applied for and got a sabbatical, bought a 42-foot catamaran, and moved his wife and 3 lovely daughters aboard. They picked the boat up in La Rochelle, sailed to the Azores, Canary Islands, I think, made it to the Caribbean, crossed over from the Bahamas to Florida and started heading up the waterway. And in Georgetown, South Carolina is where they got struck by lightning. And the strike was so bad that it ended their trip. So they had to go home. And the boat has a generator technology that you may be familiar with called Integral. It's a UK design. It's a pretty clever product, very clever in many ways, in that it's like an alternator on steroids, but the secret sauce is it's able to monitor the diesel engine's load and adjust its output based on what it thinks the diesel can support. And so they're typically rated 9 kilowatts. But if you're at anchor and running the engine in neutral, you get the 9 kilowatts out of it. And it's space efficient too. But if you're motoring the boat, the electronics may sense that, this diesel's starting to get hot, starting to get loaded. So we're only going to allow 3 or 4 kilowatts. So at least you get the 3 or 4 kilowatts, which is a lot. But the real benefit is it helps keep the diesel engine loaded. And the other thing we've seen over and over again, which I saw on my own boat, is that persistent low loading of diesels, there's no getting around it. That's not a good life for a diesel. So we are dealers for Integral, and that's why the customer reached out to us for help. So the boat is presently en route to Annapolis. It's going to be down on the South River, and it will be there for all the corrective work that the boat needs. So just about everything electronic is going to be replaced. So we're doing our part. Other vendors are doing other parts in terms of chart plotter and electronics and things like that. But getting back to lightning, to me, it's still there's still a lot of anecdote. I met a guy in Florida who swore by he would go to the gun stores and buy the wire brushes that gunsmiths use to clean gun barrels and other components on guns. I'm not a gun guy. I don't know the details of it, but he had this collection of these brushes. They have what appears to be like an aluminum cylinder, 10 millimeter, a centimeter, maybe 7 centimeters, 8 millimeters, I'm sorry, in diameter, and very fine bristles, steel bristles coming out. And he would get in his bosun's chair, have somebody lift him up, and he would put them on his masthead. And with a U clip or something like that, so to make sure that it's electrically connected to the mast. And his theory was those fine bristles help dissipate the charges that are trying to accumulate right when the lightning is trying to figure out where to strike. It wants those negative charges to mate it up with. He says these brushes help dissipate those negative charges. I can't confirm. I can neither confirm nor deny, as the politicians say. But from what I've seen of lightning strikes, I guess the good thing about solar is because it's more affordable now than it was. You're not losing as much compared to if a lightning strike fries a $20,000 generator's controls, and just to track down the parts and get the technician and all of that is $5,000 or $6,000. Lightning damaged solar panels you can probably replace for a lot less.
Can I pop in with a question from Malcolm? Did a survey on a lightning struck sailboat that fried the engine and transmission as well as all electronics?
Yes, so the boat the lightning strike actually happened in late May. The boat was only able to leave Georgetown, South Carolina with a delivery crew just a few days ago because the engine controls were fried. And parts had to be obtained, which these days is hard. Just with supply chain disruptions and things, and backlog. Engine manufacturers are backlogged, generator, we're all backlogged. And finally, yes, so the engines have been inoperable until about a week ago, when the parts finally came and the technician was able to install them, and all of that.
Questions?
Any further questions? Was this helpful? Interesting? All right, I'm glad to hear it. And I have cards, and if anyone wants a copy of this in PDF form, I'm happy to send it. Just grab a card. And thanks very much for having me.
Thank you, Dave.